Um, Good afternoon, everyone. Um, it's me. So yeah, bad news. I just got hit with COVID, so I won't be able to come into class for the next coming days until I get better. Please forgive my voice if it's a bit soft, but yeah, it's quite difficult to talk. Um, but we'll try our best anyway. Okay. So this is chapter 4F. So the main goal here is finding the area of sectors and finding the areas of composite shapes when sectors are involved as well. Okay, so it's technically level 2 of composite shapes, but we'll see how it goes. Okay, so the whole goal for this chapter is to know what a sector is, and you can find the sector's area by taking the fraction of the area of a circle, and then with the radius, there's like a specific formula that you got to do, and that's it. Yeah, so let's just give it a go. So we'll start off with step one. So what's a sector? So it's technically like you can think of it like a slice of pizza or a slice of pie. Okay. So it's like a little slicer that you see, but it's a part of a circle pretty much, yeah. So if you were to draw a circle, you're just looking at one section of it, yeah. So this section right here. So that's mainly it. Now, not all sectors are going to look nice and pretty. Some sectors can look like this one. They can look a bit like this as well. They can look weird overall in general, pretty much, but there is a way to specifically find what we're looking for. Now, the most important thing is you need to find the internal angle here. So this internal angle is the angle that we will be using to help us find the area of such sectors. And you will also be given two radii. So the radii is pretty obvious. It's just radius. Okay, radii is the plural form of radius. So you're going to need to find out what the radius is or if it's given to you already. Um, so yeah, two things that you need to find the area of a sector, the angle, make sure it's in degrees. That's the most important thing. And then you need the radius. Okay. So this is the formula that we are going to be using. Area of a sector equals to angle over 360 times pi r squared. Now, just remember pi r squared is the same thing as pi times r squared, just like that. So don't get confused too much when I'm talking about it. This 360 here, okay? So in a circle, okay, it angle overall is 360 degrees. So that's the total amount. And then when we're looking at sectors, we're looking at fraction of that circle there. So that's why we have our formula as angle over 360. So we're just looking for that fraction and we're working with that specific fraction only. Okay. Now, the reason why this works is pi r squared is the area of a whole circle and you're just looking for a piece of it. Okay. Let me just. Okay. So I have two examples here. I've just got two separate slides, and then I'll just go do the solutions on there pretty much. So over here, this is example one. So I have a sector here where I have an angle of 120 degrees and I have something called 2 centimeters here. So I would always start out by labeling what's what, okay? And just remember when you're looking for the angle of area of a sector, you're only looking for these two things, the angle and the radius. So the radius in this case is 2 centimeters. And the internal angle, remember, we need the internal angle as mentioned. Where is it? No, not here, not here. Well, you need the internal angle. So you need this angle here that I'm highlighting in the red. And as you can see, that 120 degrees that's already on the diagram tells us already, okay? So I know that my angle, or you can write it out, equals 120 degrees, okay? I would then just write out my formula for area of a sector. So A is equal to angle over 360 times pi r squared. And the next thing we're going to do is substitute r and my angle into their respective positions, okay? So this will now become 120 over 360 times pi um, 2 squared. And if you just type this exactly into the calculator, um, my calculator is a bit big, so I do. Oh no, um, no, please. How do I reduce the size there? Okay. Okay, so if I type in 120 over 360 times pi times 2 squared, because my radius is 2 centimeters. If I submit that, it gives me 4 pi over 3. Now, back to our original question, it's asking here to find the area to two decimal places. Now, to convert this into two decimal places, just remember on your calculator, just above the enter button, or aka your equal sign, there's this double arrowed button here that will convert it to a decimal, okay? So I have here 4.188. Now, because we're looking at two decimal places only, we have to cut it off around here where the first 8 is. Just remember to rounding. You got to look at the next digit after that arrow. If that um, number is between 5 to 9, you round up. Um, what that means is this number in the green here will increase by 1 if we are rounding up. If we are rounding down, then the green digit stays the same, okay? So um, because my 8 here in the, I won't use orange, I'll use a different color. I use yellow. Yeah. So my 8 in my yellow spot here, because it's between 5 to 9, we have to round up. So my 8 in the green and purple position has to increase by 1. So it will now become 4.19. And just remember your units of measurements at the end, centimeters squared. So we always write squared because we're finding the area, okay? So just remember, when the question asks for area, always put in the squared at the end. Now, for number 2, this one's a bit tricky, but I'll show you how to do it, okay? Um, so I've got 5 meters as my radii here, so that's pretty straightforward. Now, I have here 70 degrees, but that's the exterior angle. That's not the interior angle, okay? So, what we need is this angle, which I'm going to highlight in purple right there. And I'm going to shade it as well. So that is the angle that we need to find. Now, because you know that the circle, the total amount of degrees is 360, to f- and we're given the exterior angle 70 degrees, what you're going to do is subtract 70 from 360, okay? And that just ends up being 290 degrees. Now, this is the angle that we are going to use in purple. So this this angle right here in the purple is 290 degrees. Now that we have what we need, we can just substitute it into the formula. Okay. So I'll just write out the formula again. So it will be 290 over 360 times pi times 5 squared. And if you type this exactly on your calculator, 290 360 times pi times 5 squared. So I get this weird number here, 725 pi over 36. Now, because we are rounding up to two decimal places, on our calculator, just press this funny double arrowed button. So now becomes 63.268. And just check your rounding again because so purple is where I stop at, and my digit on the yellow arrow is between 5 to 9. I now round up my 6 to a 7. So it becomes 63.27 meters squared. Okay. Just like that. Now you can try this out. Um, I'll probably just find the final answer. But if you just follow the same steps as my examples here, you should be able to get the same answer that I achieved. Alright, so these are my solutions here after I've just worked out the activity questions. Working out is pretty much right there, so just feel free to have a look, okay? Alright, so this is finding areas of composite shapes with sectors. So just remember a sector is a part of a circle again, okay? Just any fraction. It could be like the ones you've already seen, like for example, a quarter circle or a semicircle slash half circle, stuff like that. Could be those ones as well, but yeah, like it's just any fraction of a circle, okay? So it's saying here find the area of this composite shape, correct to nearest whole number, okay? So just take that into account. Now, I would usually start out by shading what it is that I want. So that's what I'm doing with purple here. So that's what we want, okay? So that's the end goal, okay? I can see that in my diagram here, I can pretty much make a rectangle with like those dotted red lines already. And we're given the measurements of the length and the width already, which is 20 millimeters and 10 millimeters. So length is 20 millimeters and width is 10. So why don't we start out by finding the area of this rectangle? So A rectangle equals L times W, 20 times 10, which equals to 200 millimeters squared. Okay, so that includes the purple and the little white area there. So I'm now going to shade in this section of the sector here in green. Okay, so this green here, it pretty much looks like a quarter circle. Okay, so it just depends on what shape you're given. You have to use intuition to pretty much determine like what angle you plan on using. But most of the time it's already given. Okay, so in this case it's already given because over here this is a right angle, and in a right angle it's pretty much 90 degrees. Okay, so now that I have that in mind, I can actually find the area of this little um, quarter circle now. So I now have angle over 360 times pi r squared. Um, but then again, you're going to ask, oh, what's my radius? Well, as you can see in yellow, underlining, this 10 millimeters for the width of the rectangle is pretty much the same width here as well. Okay, so if my left side is 10 mils, that means this right side of the rectangle is also 10 millimeters. Hence, because this is a quarter circle, I can determine that 10 millimeters is actually my radius. Okay, so now I have everything we need. So just substitute everything into the formula, 90 over 360. I'll just rewrite that again. Times pi times 10 squared. And if you just type this on your calculator, I'll get 25 pi. But because we need a whole number, we need to sort of convert it to a decimal first, okay? So I end up with 78.5. And because we need whole number, we need to get rid of, check out this 5 here. And just remember the rules for rounding up and down still apply. So in this case, we are going to round up. So it will now become 79 millimeters squared. And that is what the area of the purple shaded area is. No, no, not really. That's a joke. Um, so actually, uh, that's just the area of the green section. Now, to find the area of the purple section, we need to uh, subtract the area that we just found in the quarter circle from the rectangle, and that is how we get that purple section there. So, so A total equals to 200 minus 79, which equals to 121 millimeters squared. And I'll try and find a way to move this in a bit closer. I can. Mm, no, I can't. Oh, so yeah, that's the closest I can get it, okay? Oh, whoops, I should have done it here. Oh well, same thing. Um, see, I'll leave you to it, okay, for this one here, and I'll just create my solutions in a couple of moments, and I'll show you all how to do it. Oh, I'll just show you the solutions, I mean. Alright, so this is my answer, okay? So you should have got 99.47 millimeters squared. Just to quickly explain it, I've got technically a rectangle here if you include that red dotted section. So the length is 20, the width is 10 millimeters. So you just find the area of that rectangle first. Now, that circle in the green is a half circle, okay? So the angle that we are going to get from a half circle is 180 degrees. That's why my angle here is 180. Now, the length 16 millimeters here that's technically the diameter of the circle. But to find the area of this half circle, um, all you had to do was divide the diameter by 2, and that's what gave me 8 millimeters. Once you find that, you subtract it from your area of a rectangle, and that's how you find the area of the purple section. Now, you didn't even need to use the sector formula for this half circle here. If you just remember the area of a half circle, which I taught you from earlier, was pi r squared divided by 2. So if you just did this, you would have been fine as well, because you would have gotten the same answer. Okay. So yeah, that's just the end of it. Good luck, have fun. Um, there won't be detentions, okay, obviously, because I'm not available to check your homework. But please do make sure that when I come back, it gets done. So I'm holding you all accountable to your homework. Once I do come back, if there are some things that are missing, that's when we'll start holding detentions, okay? But other than that, just enjoy the rest of the week, okay? Please don't miss me too much. I'll try my best to come back as soon as I can. Take care.